This will be a presentation on Chapter 4, Fasteners and Measurement Equipment. Methods of collecting data depend on what's being measured. Checking for excessive wear or damage when servicing components is critical to proper service. Some shops send components out for machining based on a technician's diagnosis of wear. Automotive components are held together with a variety of fasteners. Most common measurements in the United States is the USCS, which is based on the inch. It can be measured in decimals or fractions. Engine and brake measurements are expressed in thousandths of an inch. 1,000th of an inch is expressed as 0.001 inches. Rulers and other measuring instruments can be expressed in a variety of increments, 8ths, 16ths, 30-seconds like a tape measure, or possibly tenths, 50ths, or hundredths on some steel scales. A working knowledge of fractions is important in automotive measurements. Please note the United States is basically the only one that still uses this USCS standard. Inches and feet are only used in the United States. Most of the vehicles we have manufactured in this country over the past 20 or 30 years are typically what we call dual dimensioned. That means they're dimensioned for both USCS, inches and feet, and also to the metric system, which we'll discuss next. The metric system is based on the meter. The most common units in the automotive industry are centimeters and millimeters. Millimeters are used to express close tolerances, such as engines or brakes. Metric system is based on multiples of tens. 1 meter is equal to 100 centimeters, which is equal to 1,000 millimeters. 1 millimeter is equal to a tenth of a hundredth of a centimeter, which is equal to a thousandth of a meter. So these are typical measurements in automotive metric measurements. Measurement conversion is critical. Sometimes we needed specifications are not stated in the necessary format. To ensure correct conversions are being applied, we follow conversion charts. Most common two conversions, and I might recommend that you remember these two. To convert inches to millimeters, you multiply by 25.4. Convert millimeters to inches, you multiply by 0.03937. You can usually round that up to 0.04 for 100ths of an inch. For reference, I'm showing a couple exact measurements that come from a spec. Diameter of a brake drum in inches is 9.094. We convert that with a 25.4 factor, and we get 230.99 millimeters. And to go the other way, 231 millimeters times 0.03937 would equal 9.094 inches. So you can see how this goes back and forth and works either way. This is where we got those specifications from. This is actually out of the Chilton Care and the Cengage program. For those of you that don't realize it, Cengage does have a Chilton Care in its format. You can actually go in and use that like you would use Pro Demand in the shop at school. So if you've signed up for Cengage and you can get into the program, there's actually the same type of information we have at school available to you through the Cengage program. These are typical conversions, and you can see how they work. Rulers are a simple tool measured straight using to measure straight line distances where tolerances are not a major factor, like a tape measure for measuring houses. They may be USCS or metric. They can be metal, plastic, or wood. Typically, rulers are 6 or 12 inches. We don't usually use rulers in vehicle repair. Feeler gauges are commonly used in automotive. They're thin, machined flat pieces of metal, and they can be used as illustrated in the sample below to measure a gap between two components. The 2,000th blade goes, the 4,000th blade doesn't go. So we can say that that gap is approximately 0.02 of an inch. Rulers and feeler gauges can also be used to measure flatness. The illustration here is measuring a cylinder head. We can tell that because it has valves, intake and exhaust ports, and passages. And the feeler gauge and straight edge are used to measure whether or not the head is warped. Micrometers and associated gauges are commonly used in automotive. Micrometers precisely measure different shapes of a component. We've got several types of micrometers. Typically, the outside micrometer is the closest, the most common one. Sort of resembles a clamp. Measures linear distances on a round object. Proper techniques require a little bit of practice. Typically used to measure bearing journals, shaft diameters, possibly even rotor thicknesses. Another type of micrometer is an inside micrometer. It's used to measure an inside diameter, like a cylinder bore. There are specialty micrometers that can be used to measure a brake caliper or a brake drum. Outside micrometers have major components: a fixed handle, spindle, thimble, and a barrel with scales. The scales can be marked in a variety of different increments, but typically are marked in 1/1000th of an inch increments. Micrometer calibration is critical, and the micrometer must be accurate to itself. Typically, it's easy to perform, and most micrometers come with the necessary equipment to do it. Reading a USC outside micrometer is easy enough to do. We simply place the handles against the work. We rotate the thimble to bring the spindle into contact. Use the ratchet knob to assure that sufficient contact is made. Remove and read the micrometer. This is an example. The ratchet would be to the right. We measure the diameter, and typically we measure this by rocking it back and forth. We use the ratchet to ensure that we don't over-tighten it or under-tighten it, because the proper fit is critical to getting an accurate measurement. Micrometers for metric read similar to USCS, only the barrels are marked differently. This is a typical micrometer set. Whether it would be a USCS or a metric set, this is not going to make any difference. I've circled here to show that this is a set that measures 0 to 1 inch on the vertical on the right, 1 to 2 inches on the top, and 2 to 3 inches on the bottom. That's the thing, micrometers are designed to measure 1 inch ranges. Each one of these micrometers measures from 0 to 1, 1 to 2, or 2 to 3. And that's for metric or USCS micrometers. But typically the barrel and thimbles are all the same, and it's just a matter of the size of the frame. Brake micrometers are used to measure brake rotor thickness and drum diameters. Markings are somewhat different, and construction is a little varied from regular standard micrometers. This is a brake micrometer. You'll notice it has a pointed anvil on one end. That's in case there is a wear in the brake rotor, so we can get to the bottom of it. And you'll notice it's a little deeper barrel, because typically we want to measure across the range of flat surface on the brake rotor. But again, the measuring part is 1 inch range. And typically a brake micrometer measures from approximately 1/2 inch to 1.5 inches, which covers the greatest majority of brake rotors. Dial indicators are used in a variety of different functions. They check how far a component can move, USCS or metric. The face can be used to determine a total indicator reading. It's not necessary to zero a dial indicator. We are simply concerned with how far does the needle sweep, from what to what. That's why it's referred to as total indicator reading. If we go from 15 to 25, or we go from 25 to 35, the result's the same. Total indicator reading would be 0.10 So it's not necessary to zero a dial indicator. It can typically be used in any given range, and that total indicator reading is the measurement we get. Another common tool used is a dial caliper. This one is dial caliper. Most of the modern tools today are digital. We can use 3 different measurements with this caliper. We can measure the one jaw, OD, the other jaw is ID, and on the right-hand side, it'll extend and we can measure depth. So it's a very useful tool. It is not as accurate as a micrometer, and typically one dial caliper will measure from 0 to 6 inches. A variety of gauges are used in automotive, pressure and vacuum. Pressure measures the amount of pressure applied to a closed-sealed system. We can take that and check, like the gauge we have here, and measure pressure. They can be scaled to different ranges and different amounts. A vacuum gauge, as you'll notice on the gauge illustrated here, can actually, this is, if you read the picture carefully, you see this is a fuel pressure gauge. It goes to 15 psi. This is what a standard old-fashioned mechanical fuel pump pressure range would be. On the other side of the gauge, you'll notice where the needle is approximately 0. And we scale 1 to 15 on positive pressure, which is measured in psi. And on the other side, we measure from 0 to 30, which is measured in inches of mercury. And that's how we measure vacuum.